There is one direction in the sky that humans have never been able to look. Not because we lack the telescopes, because our own galaxy is in the way. We sit about two-thirds of the way out along one of the Milky Way's spiral arms, which means we are looking at the rest of the universe through the body of our own. In one broad band across the sky, the dust and gas and crowded stars of the galactic disk form a wall. Almost nothing behind it reaches us in visible light. Astronomers call that band the Zone of Avoidance, and it seals off something close to a fifth of the sky, permanently. And of every direction it could have been, the thing dragging this galaxy across the universe sits exactly behind it. We have known something was there since the 1980s. We gave it a name, the Great Attractor. And when we finally found ways to see through the wall, what we found did not solve the problem. It made it worse. Start with how we know we are moving at all, because it is not by looking at anything. Point a sensitive enough antenna anywhere in the sky, and you pick up a faint hiss of microwaves. That is the cosmic microwave background, the cooled afterglow of the Big Bang, filling all of space at about 2.7 degrees above absolute zero. It is the oldest light there is. In a universe where we were sitting still, it would arrive almost perfectly even in every direction. It does not. One side of the sky is very slightly hotter. The opposite side is very slightly colder. The difference is a few thousandths of a degree. But that pattern has only one sensible explanation. We are moving. We are running into that ancient light on one side and away from it on the other, and it is shifted in frequency ahead of us, the way the pitch of a siren rises as it approaches. Measuring something that small was not easy. In the mid-1970s, George Smoot bolted a differential radiometer into the nose of a U-2 spy plane and flew it to 70,000 feet above most of the atmosphere to compare one patch of sky against another precisely enough to see the effect. A Cold War reconnaissance aircraft, repurposed to find out which way the human race is drifting. Convert that temperature difference into a speed, and you get a number. 630 kilometers every second, 2.2 million kilometers an hour. By the time this video ends, you will be almost twice the distance to the moon from where you started, in a direction you did not choose. You cannot feel it. There is nothing to feel it against. But the oldest light in existence is keeping score, and it says we are falling somewhere. Knowing you are falling is not the same as knowing what you are falling toward. Through the 1970s and 80s, a group of 7 astronomers set out to work that out. Alan Dressler, Donald Lynden Bell, David Burstein, Roger Davies, Sandra Faber, Roberto Turlevich, and Gary Wagner. The literature still calls them the 7 Samurai. Their method was patient and unglamorous. They measured hundreds of elliptical galaxies, worked out how far away each one actually was, then compared that against how fast each one appeared to be receding. In a universe that is only expanding, those two numbers should agree everywhere you look. Any disagreement is not expansion. It is real motion laid on top of the expansion, a galaxy being pulled by something. The disagreements did not scatter randomly. They lined up, galaxy after galaxy, across an enormous volume of space, all leaning the same way. Our galaxy, the local group, the Virgo cluster, thousands of others, an entire region of the universe streaming together toward one point in the direction of the southern constellations Centaurus and Norma. They published it in 1987. Something with the gravitational reach to move a region of space hundreds of millions of light years across was sitting in that direction, and Alan Dressler gave it the name that stuck. Consider what that claim actually was. They had not detected an object. They had not seen a glow or a silhouette or a single photon from the thing itself. They had measured the drift of hundreds of separate galaxies, noticed that the errors all leaned the same way, and concluded from the pattern alone that something enormous had to be sitting at the focus of it. They could not see a thing there. They named it anyway. Here is the part that should bother you. The direction they had just identified was the one direction they could not examine. Look at the Milky Way on a clear night far from any town, and you can see the problem with your own eyes. That pale band across the sky is the disk of our own galaxy, seen edge on from the inside. Beautiful from here. From an astronomer's chair, it is an obstruction. Interstellar dust does something specific to light. Grains roughly the size of smoke particles scatter and absorb short wavelengths far more efficiently than long ones. Stack enough of them along a line of sight, and visible light from anything behind them simply does not arrive. Then add the crowding, hundreds of billions of foreground stars packed into that band, drowning out anything fainter behind. The result is a region where extragalactic astronomy stops working entirely. That is the zone of avoidance. It is not a place, it is a blind spot, and it is enormous. For most of the 20th century, the galaxy catalogs simply had a gap running through them, a stripe of nothing wrapping the sky. Not because nothing was there, because nobody could check. And the gravitational center of everything we could measure sat inside that gap. This is not a small technical annoyance. Everything we claim to know about the mass of our own corner of the universe carries an error bar that exists purely because of it. We are not describing the neighborhood, we are describing the part of it visible from one obstructed window. The universe had put the answer in the one place we were structurally unable to look. Dust blocks visible light. It does not block everything. Long wavelengths pass straight through it, so do very short ones. Radio telescopes can map the hydrogen gas inside galaxies right through the galactic disk. Infrared surveys pick up the heat of stars whose visible light has been extinguished. X-ray observatories see the gas that fills massive galaxy clusters, glowing at millions of degrees, entirely indifferent to how much dust is in the way. Through the 1990s and into the 2000s, astronomers went after the zone of avoidance with all three. And things began appearing in the gap. The most important of them is cataloged as Able 3627, the Norma cluster, a galaxy cluster sitting almost exactly at the predicted center of the flow, roughly 220 million light years away, and comparable in mass to the Coma cluster, one of the most massive structures known anywhere. It had been behind the galactic plane the entire time. One of the largest objects in this region of the universe, missed for a century because it happened to lie in the wrong part of the sky. Around it, more began to resolve. A wall of galaxies, filaments feeding inward, a structure massive enough to be precisely what the Seven Samurai had predicted from the motion alone. So that was it. The Great Attractor had a face. Textbooks were updated, diagrams were drawn, and the mystery was filed, more or less, as solved. Then somebody added it up. Take everything visible in the Great Attractor region. Every galaxy, every cluster, the Norma cluster at its heart, all the hot gas the X-ray telescopes can find. Total the mass. Work out how hard that should be pulling on the Milky Way. It is not enough. Not by a little. The Great Attractor region accounts for roughly 44% of our motion, less than half. The thing we found, named, drew diagrams of, and treated as the destination is responsible for under half the pull. The larger share of that 630 kilometers per second is coming from somewhere else entirely. And when astronomers traced where, the answer came back in the same direction, further out, much further. Roughly 650 million light years away, close to 3 times the distance to the Great Attractor, sits the Shapley concentration, the largest concentration of mass in the nearby universe. On the order of 10,000 Milky Ways worth of galaxies packed into a single region, something like 4 times the mass of the entire Great Attractor, which means the Great Attractor was never the thing pulling us. It is something else being pulled. That entire structure, the Norma cluster, the wall of galaxies, the region massive enough to drag 100,000 galaxies, including this one, is itself falling, in the same direction we are, toward the same place. We spent 40 years chasing what was pulling our galaxy. We found something enormous, and we stopped, because enormous felt like an answer. It was just the nearest thing in the current. The Shapley concentration is named after Harlow Shapley, who noticed an unusual density of galaxies in that part of the sky in the 1930s and had no framework to explain it. He was looking straight at it decades before anyone understood what they were looking at. It lies toward Centaurus, the same broad direction, further along the same line. At its core is a chain of galaxy clusters, Abell 3558 and its neighbors, packed so tightly that they are not merely near one another. They are merging, colliding, over billions of years, in slow motion. To feel the scale of it, climb the ladder. Our galaxy holds a few 100 billion stars. The local group, us, Andromeda, and a few dozen dwarfs, is a small huddle by comparison. The Virgo cluster, which dominates our local sky and pulls on all of us, holds well over 1,000 galaxies. And the Shapley concentration holds tens of thousands of galaxies worth of mass, concentrated tightly enough that its gravity reaches across 500 million light years and drags on structures that are themselves dragging on us. We are not falling toward the Great Attractor. We are falling past it. And there is something quietly unpleasant about how this fall actually feels, which is that it does not feel like anything, and it never will. The Milky Way is not going to be torn apart by Shapley or arrive somewhere and be crushed. Our galaxy will collide with Andromeda, the two will merge, and that combined object will go on drifting in exactly the same direction, at the same imperceptible rate, carried by a gradient it cannot resist and will never notice. The horror here is not violence. It is that the largest motion we are part of had to be inferred from a temperature difference of a few thousandths of a degree, and that it will simply continue, regardless of anything. And that raises the question nobody can answer cleanly yet. Is Shapley the bottom? In 2014, a team led by Brent Tully tried to settle a related question properly. Instead of asking what is bright, they asked what is falling where, mapped the velocities of thousands of galaxies, trace each one's motion backward, wherever a set of galaxies all drain toward the same gravitational low point, draw a boundary around them, the same way you would define a watershed on a continent by which way the rain runs. The basin containing the Milky Way turned out to be about 520 million light years across, holding something like 100,000 galaxies. They called it Laniakea, Hawaiian, roughly immeasurable heaven. For the first time, we had an address. And the floor of that basin, the point everything in Laniakea drains toward, sits in the Great Attractor region. Then the data got better. More recent work with the Cosmic Flow Survey suggests Laniakea may not be a basin at all. It may be a slope. The measurements are consistent with Laniakea and its neighbors, all draining onward into the Shapley Basin, a structure something like 10 times Laniakea's volume, with our entire 100,000 galaxy supercluster sitting inside it as a minor feature on a wall. Every time the survey goes deeper, the basin gets larger. Every answer has turned out to be a component of a bigger answer. And at the edge of the data sits something nobody has fully explained. Several surveys of cluster motions have reported a bulk flow. Hundreds of clusters across an enormous volume, drifting together at around 1,000 kilometers per second toward roughly the same part of the sky. It has been called dark flow. If it is real, it is not accounted for by Shapley or Laniakea or anything in the standard picture of how structure forms. The measurement is contested and may dissolve as the data improves. But notice what the argument is actually about. Not whether we are being pulled, only whether the thing pulling us lies inside the observable universe at all. There is no version of this yet in which we have found the bottom. Which brings us back to the wall. All of it. Every basin, every boundary, every estimate of how much mass is sitting where rests on a map with a stripe of missing data running through it. And the missing stripe lies over the most important part. So, in the last 2 years, the approach has changed. In 2025, the James Webb Space Telescope was turned toward the Zone of Avoidance and resolved faint galaxies straight through the galactic plane in the infrared. Objects that had been sitting behind the dust, unrecorded, since the first galaxy catalogs were ever compiled. And a few months after that, a group published something stranger. They trained a neural network on simulated universes, artificial cosmologies where the correct answer is already known, and then handed it the real incomplete data. The network fills in the zone of avoidance. It reconstructs the dark matter density, the gravitational potential, and the velocity field across the region nobody can observe. Sit with what that means for a moment. The best current picture of what is pulling our galaxy is, in part, not an observation, it is an inference. A machine's most probable guess about the shape of something behind a wall, calibrated against universes that were never real. And there's a loop buried in that which is hard to get out of. The simulations the network learned from were built on our current assumptions about how matter clumps and flows. So the reconstruction it returns will, by construction, resemble the universe we already expect. If what sits behind the zone of avoidance is stranger than our models allow, this is the least likely method of all to tell us. Every step here has been reasonable. Not one of them has been a direct look at the thing dragging us. So here is where it stands. You are moving at 630 kilometers per second toward a region of the sky you cannot see, pulled mostly by something 4 times more massive than the object we named, which is itself falling in the same direction, inside a basin that increasingly looks like a slope into a larger basin we have not finished measuring. And you will never arrive. Laniakea is not gravitationally bound. Neither is the flow toward Shapley. The space between all of these structures is expanding, and that expansion is accelerating. For now, gravity is winning locally, and we are genuinely being drawn in. But the pull weakens as the distance grows, and the expansion does not weaken. At some point, long before anything reaches anything, the two curves cross. The current stops. The destination begins to recede. Everything outside our own bound neighborhood drifts beyond reach, then beyond sight, and the sky empties. We are falling toward something we cannot look at, that is not the thing we thought it was, that is itself falling, and that we will never reach. The Seven Samurai found the current in 1987. Everything since has been the slow discovery that it runs deeper than anyone expected, and that it does not lead anywhere we will ever stand. There is a question in all of this that people tend to split on, and it is not really an astronomy question. Some find it genuinely reassuring that a species on one small world, inside an obstructed galaxy, can correctly describe a current 500 million light years across. Others find that the single most disquieting part of the whole account. Both readings fit the same evidence. Only one of them lets you sleep. The universe is not hiding the answer out of malice. It simply put a galaxy in the way and started the clock. The void is patient. Subscribe.